All right, so let's take a look at this question here. So it says that f of x is equal to x cubed, and I guess for this thing I left it out, but we can assume here that since this is all about inverses, that g is the inverse of f. And it tells us that y sub 0 is 27. So different notation that we haven't really seen before, but here we're going to assume, well, based on this thing here, that y sub 0 is in f. Right? So essentially what that means is that in f we have the point, we'll say x comma 27, whatever that happens to be here, where that's going to be the coordinate. So in g, since it is the inverse of it, it's going to be at 27 comma x. All right, so that's going to be our setup here. And so for this thing, if we're taking a look at the setup for this, we are asked to find what g prime of y sub 0 is. And so it's essentially just telling us what is g prime of 27. Okay? So we can fall back on what we saw, or we did on the previous page, which is that g prime of x is equal to 1 over f prime of g of x. Okay? And so we're trying to go through here and do g prime of 27, which is 1 over f prime of g of 27. Right, so as we're looking at this thing here, what we need to do is we need to find out what g of 27 is. Okay, so if we look back here, I know that in f, this is 27 equals to x cubed. So I can solve for the x value. I can take the cube root of both sides and get x equals to 3. So what that means is the coordinate pair in f is going to be 3 comma 27. Right? So that means that when we talk about this in g, this means that I have the point 27 comma 3. Right? So that's really helpful because that means that when x is 27, the corresponding y value for g is going to be 3. So I can plug that in here. So I have 1 over f prime of 3. Right? So the only thing that's left here is what is f prime of 3? Well, f of x is equal to x cubed, so f prime of x is going to be 3x squared. Right? So that means that f prime of 3 is going to be 3 times 3 squared, or 27. Right? So this ends up being 1 over 27. And there's our answer.